How's it going, guys? Andrew with American Diesel. Hope you had a great new year. Got a 2018 Ram 2500 with the 6.7 Cummins, and I had a whole bunch of codes on here, but I figure I'd show this one since this is a really unique failure, and also too, it's just some testing that I came up with that has worked very well with for me. And I just got to say, like, you know, you could do pinpoint testing. You know, take off the connectors and ohm out this and ohm out that, and then follow the directions of what, you know, whoever it may be, pro demand, all data, you know, OEM information. You can follow that for sure. But as far as me being a diagnostician, you know, I like to make sure that whenever I'm checking out a component, that I know I'm not leaving anything out. So whenever you ohm out wires and you're ohming out this and you're testing it the way the engineers wanted you to test it, I mean, they don't think about everything. So let me just show you what the fault I'm talking about, and then that way you can understand what I'm talking about. So gonna go here to snap on, gonna go to engine, codes menu, codes. Okay, I already cleared the fault, so now I'm gonna actuate it, and then that way you can see the fault happening. Let's go to functional test. So the fault that this vehicle is having is the intake air throttle, which is basically they call it a couple of different things: the EGR, throttle plate, EGR this, EGR that. Basically all it is just this throttle plate that's right here that goes right before this mixing duct. What it does, it closes, that way it can bring up the heat for the EGR, that way it can better burn. So we're gonna go to here. Gonna go to custom. I just want to be able to look at the PIDs. That's gonna help us out. So this one, and this one. Okay, list view. Okay, so I want you to watch these two PIDs here up on top. One's the commanded and the other one's the actual position. So as soon as I command this on, this is gonna go down to 6, which it did, and this one's staying right at 99%. So 99% is all the way fully open. And as you can see, it didn't move, it didn't budge. And then after a while it gives up, goes back to 99. And then after that point, right here where it comes back up, gives up, it throws that code. So come back, exit, come back one more time, codes menu, and that code should be active now. Yep, there it is. So it's going to be P02E3. That's the one that we're attacking today. And then also P02E7. Let's go back. Okay, so we'll leave that right there. So now that what we're gonna do is I want to disconnect that connector, and I want to simulate basically a good throttle valve with nothing but just a test light, and also to a resistor. That's it. That's all we're gonna do. Okay, but also too, so just in case, I mean, this is pretty cheap to have something like this, like to make something like that. I mean, it's less than 15 bucks. to make something like this, just a little test light. And then as far as this right here, this little resistor I have, a variable resistor, you don't have to buy something like that. You could just buy one of those little pellet resistors and do something like that, and then have one side to ground, and then the other side you're going to put it to this wire that I'm going to tell you. So, and I guess another way you could do it, which I'm about to share right now, which you can just check voltage with your meter, which that's why I have my power probe right there. You just disconnect the connector, and then we could just check voltage right there. You can do it like that. It doesn't eliminate everything, because you're not actually checking the load on there. You're not actually doing that extra little step. But I mean, if that's all you have is just a meter, and that's all you have at home, well then, you know, it'll get you about 90% there. I mean, if the code comes back up, I mean, it sucks for you, but that's why I'm trying to show you this last way of doing it. It's just pretty much a foolproof way of how to get that code to come off. So what I'll do is I'll put this in place, which is this test light, and then that potentiometer. And then what I'll do is I'll activate it one more time on my snap-on, and then you'll see that the code does not come back. And yeah, that's pretty much it. So yeah, let me get this set up, that way I can show you the other way you can test it, and then I'll show you my way of testing it, my foolproof way that I came up with to test it. And then that way maybe you can take this with you and use it elsewhere, because this just only doesn't work just for this. It works for any type of valve really, where you have a power and ground and then a potentiometer. So whenever I take this off, I'll show you why you have to do it the way that I'm showing you, because if you don't, it's going to throw you for a loop. All right, so let me get this set up. All right, so let me show you what we're going to be checking. So this right here, the EGR airflow control valve, it's a 5-pin connector. Pin number 1 being the positive, pin number 2 being the signal, number 3 is a center ground, 4 5-volt supply, and then 5 is going to be your ground for that throttle motor. So with now that I have it disconnected over here, which it's right here, I'm going to show you, just checking the pins, what you're going to see. So pin number 1, check it over here. That's going to be our positive. So yep, 12.3. And our second pin is going to be our sensor signal, and that's going to be at 5 volts. Okay, next pin is going to be number 3, which is going to be the sensor ground, which show the ground. Pin number 4, which is going to be 5-volt reference. Yep, 4.99. And then this last one, it says air intake throttle motor negative. Watch. So even though it says negative, whenever you disconnect it, it automatically defaults to a positive voltage. That way, whenever you disconnect, you're checking here. That way you can be able to test it correctly. Why they did that, I have no clue. But yeah, basically, if you see that these 2 outer pins, If these two outer pins are positive, and then the ones neighboring to that, those are both going to be 5 volts, and then the one in the middle is going to be your ground. So if you get all that, you have that code, you disconnect it, check all that, you can 90% chance you're going to call it and you're going to be good. So the only thing bad about that is you're not really putting a load on the circuit. So you can go one extra step. If you have a test lamp, this is what you can do. Now let me demonstrate. So just got my test light, hooking up the banana jack. That's ground right there. And so I'm just testing just the outer pins. And as you can see, it lights up, lights up. And if you can do that at least, then you can pretty much call that valve as being bad. And that's pretty much it. I mean, as far as pinpoint testing, like I was stating earlier, they want you to disconnect this, disconnect the PCM, which is way down there. I mean, it's buried. It's really hard to get to. And then to disconnect all that and check resistance, I mean, it's just, if you're a new person, you've never done it before, I mean, yeah, you can do it like that, but that's just not how I like to do things. So, all right, now I'm gonna do my way, which I'm gonna connect to the outer 2 pins. Okay, so if you were to try it like this, if you had a scan tool, like the way I do, if you have a scan tool and you try to bidirectionally control this, so we'll go back to the here. And then I'm going to command it on, nothing. Off, on, nothing. So here's where that resistor comes into play. So I'm gonna press exit. So the reason why that didn't work with you putting a test lamp in place across the positive and negative, it's not because this is a positive and that's a positive. That has nothing to do with it. What it is that this pin neighboring number 1, which is number 2, that's your signal. If your signal is not pulled down whatsoever to give it a reference of what position it's in, it's never going to enable this circuit. So with that being said, we're going to come back to this. Okay, so all this, like I said, just going to be your ground on here, grounded to the battery, and then I'm going to put it on pin number 2. So like I said, the second one from right going to left. Okay, now I have it on the second pin. So we're going to try that test one more time. So we're going to come back to here and take your throttle. I'm going to customize the list one more time. Deselect all. Gonna go back to those PIDs that we need to get to. Intake air, intake air, intake air. Okay, list view. I'm gonna open these up. Okay. I don't know if you remember from earlier, but one was stuck at 6%. So right now, with that resistor, I'm giving it a fake reference. So from ground, all I'm doing is giving it a controlled ground. That's all I'm doing, is I'm pulling it down to ground at a controlled rate. So what I'm gonna do, I'm gonna spin this dial, get it here in the shot. Let me zoom in. So you see the value is moving down because I'm moving that resistor. That's all I'm doing. So with this resistor, which you can get from AES Wave, you can set it to whatever value you want to put it at. It doesn't really matter what value you put it at. It's just you need to put it to something, that way you can trick the computer to thinking that there is a valve in place. So with that at 60, now watch. I'm gonna do the test one more time. I'm gonna press on. Here you go. Light turns on. And that's it. So since we did those other tests with the power probe, we checked everything else. Right now we had just checked power and ground on the valve, on the circuit, actually, sorry. So we already checked here. We're here on the positive and negative that goes to that valve. And with that test light turning on, you basically load tested these two wires, okay? Also too, with us giving this variability at a controlled rate, which is that right there, with us doing that, we know that the sensor signal is good. We also know too that there's a 5-volt reference and a sensor ground. So we tested all 5 wires. What else is left? That's it. We can call that valve. Now, you can do one extra step as far as taking off the map sensor, and which I did already. I took off the map sensor. I'll show you that. So map sensor is right here, just one bolt, gets bolted on right here. Undo that, and then you can stick in a camera, maybe a flashlight, and like something else, like that way you can be able to see in there. But yeah, you just look through right here, and then while you're commanding it on and off, you can see if that throttle plate moves or not, which mine wasn't. So yeah, that's pretty much it. That's how you can test that that EGR valve. And like I said, this same system, or the same testing that I'm doing, works with many different applications. This is the same application that I first started using with the L5P Duramax. And yeah, it works here, and it works a couple of different places where the computer shuts down the circuit because it thinks that there's an open circuit in there, so it doesn't want to enable it. And yeah, so if you like that, let me know. So all right guys, I'll catch y'all in the next one. Don't forget to like, comment, subscribe, and see y'all guys later.